Hello everyone, this will probably be the last video in a while, or maybe ever, of me explaining and solving some weird math problem that my math teacher assigned my class for some reason. So today we have solve 2 sine of phi times cosine of phi plus 2 sine of phi plus the cosine of phi plus 1 equals 0 when phi is between 0 and 2 pi. So this is actually a really easy problem, actually. It's just one of those, solving trig equation and simplifying trig equation problems. So the first thing we need to do is, you see we have those sine phis and cosine phis. Well, I don't like that. So to make it easier for us to work on this problem, let's just replace all of the sine phis with x and all of the cosine phis with y. So we can rewrite it as 2xy plus 2x plus y plus 1 equals 0. Now the 2xy came from the 2 sine times 2 cosine. And if we replace it, it becomes 2xy. So now we have that, and we can just factor it. It might not look like your normal normal quadratic equation, but you can actually still factor it like a quadratic. In a regular quadratic equation, you'll have something like this, where all of the variables are the same. Well, it's the same thing here, except for the variables are different. There are 2 variables instead of 1 in your standard quadratic, but that doesn't stop you from being able to factor it. It will just end up with 4 terms instead of 3. So we can factor with the T method that I learned in my math class. You might factor it differently. But you basically, these 2 values have to multiply to be the first term. And then the values across from each other have to add up to the middle term, or in this case, middle terms, because the 2 variables are different. And these 2 values have to multiply to the last term, the integer term. So to complete it, we just need to put 2x here, y here, and a 1 on the right. And so now we have 2x plus 1 times y plus 1, and we can verify it by actually factoring this out using the FOIL method. So front, outer, inner, and last. So yeah, it does factor out to be our original equation here, which is good. So now we have it, we just have to solve it. Split it into 2 equations, 2x plus 1 equals 0, and y plus 1 equals 0. We get y equals negative 1. And x equals negative half. Now we are not quite done yet, because remember, x is actually sine of phi, and y is actually cosine of phi, so I have to actually replace it back. So now we have sine of phi equals negative half, and cosine of phi equals negative 1. Now right now we can conjure the unit circle. And we can see, where does sine equal negative half? Well, as we can see on the unit circle, sine equals negative half at 7 pi over 6 and 11 pi over 6. And the cosine equals negative 1, as we can see on the unit circle, at just pi. So here are your 3 answers. Yes, this problem does have 3 solutions. 7 pi over 6, 11 pi over 6, and pi are all values for phi here. Hope this video helped, and thank you for watching, and bye.